In this lesson, I want to look at case classes in Scala. And I note here that case classes are so important to functional programming in Scala, it's worth a quick review of what they are, the features they provide, and then the benefits of those features. So a case class is like a regular Scala class, but it also generates a lot of code for you. And that generated code has the following benefits. So number one is an apply method is generated for you. And that means you won't need to use the new keyword to create a new instance of the class. This was really important in Scala 2, but the new keyword has generally gone away in Scala 3, so it's not quite as important as it used to be. The second feature and benefit is that accessor methods are generated for every constructor parameter because case class constructor parameters are public val fields by default. So this means you don't have to annotate the fields with a val or var keyword, and definitely not the var keyword, but you don't have to use val either, as you'll see in just a few minutes. And then as I note here, we won't use var fields, but if you did, case classes would also generate mutator methods for those. But again, that's not something we have to think about in this course. An unapply method is also generated, and this makes it easy to use case classes and match expressions. And this is really huge for functional programming in Scala. And you see this note here that the biggest advantage of case classes is that they support pattern matching, and that's what is meant by this unapply method. And we'll dig into that more in this course as we go along. Also, as you'll see in the lessons that follow this, a copy method is generated. I showed this in an earlier lesson, and I'll show it again in a future lesson. I never used a copy method when I wrote OOP code in Scala, but when I write functional code in Scala, we use the copy method all the time. And we use that to create new values from existing values. And I will show an example of that in just a few moments. A case class also has equals and hashCode methods generated for you automatically. And that lets you compare objects with equals and not equals, and also lets you use them as keys in things like maps and sets. Also, a default toString method is generated, and that is particularly helpful for debugging. There's actually a best practice to not rely on this for printing if you want to print to users or something like that. So as a practical matter, it's really good when you first get started with, and it's really helpful for debugging, but you should never rely on the toString method when you're printing information for users, for example. So now to demonstrate this, let's go ahead and slide that over there. And so the first one I have here is this case class of a person. So we have case class. Remember that when you create a Scala class, normally you would say class person. And here the only difference initially is that we type case class and then person. And now the first parameter is name. So if you recall with the plain old class, we would type val name and then string like that. And in the case class, we just don't use that val keyword. You can think of it as being there for you automatically. So name is going to be a val by default, and relation is going to be a val by default. And that's the entire person definition right there. And now I could say something like, well, val Christina equals person. And notice that I don't have to say new person. But again, this is something you really don't have to do very often in Scala 3. And then I say, well, the relationship is she's a niece of mine. And there we have an instance right there. So far, so good. I note that this is a nice convenience when you're writing OOP code, but this is really a terrific feature when you're writing FP code, because these are the types of things that we want in our FP code. We want these to be val fields by default. And the nice thing is we just don't have to keep typing that val keyword over and over again for every input parameter. And in this next section, I note that there are no mutator methods. So we have an accessor method. So here we can just say, well, val s equals Christina.name. So that's the accessor. I'm accessing this field right here, and you can see that that works. But now if I try to update that field and I say Christina.name equals something else like Fred, for instance, we'll see that we get this error message here that we're trying to reassign a val field, and it says val name, and name is that field right there. So again, this doesn't work, and that's exactly what we want in functional programming. And another nice thing is this unapply method is generated for you automatically. So that lets us write code like this. So this is a match expression right here. So in Scala 3, that would look like this. We could say Christina match, and then we could say case, and then we can disassemble that. So we could say, what I want here is the name and the relation, and then I'll just go ahead and print those out. So I could print them like that. And in this case, I will do it a little bit differently and just say name equals $n, and then relation equals $R like that. And you see that that works right there. And now if I were to recreate this, I'll create a class here instead of a case class, and I'll just call this one human. And we'll just have name and I'm doing that as a plain class. So let me do the equivalent would be val name is a string like that, and we won't worry about the relation right now. And then I can create an instance of that and say val al equals a human, and the name is Alvin. And now we have that. And remember that this is a plain old class. So now if I try to do a match on that and I say al match, and then let me type in that case there. So this will be case human, and it'll just have one parameter for name. And then we can say, in this case, print line n. So now if I hit enter, what you're going to see is that this fails. And the message that's important up here is that the human cannot be used as an extractor in a pattern because it lacks an unapply method. Actually, it lacks an unapply or an unapply seek method. Right there is what that says. And again, that's because I created this as a plain class. But in this example, we didn't get that kind of error message. And again, that's because I created that as a case class right there. And that case class does generate this unapply method for me automatically. So that's why this one worked, and that's why this one fails. And we use pattern matching all the time in functional programming. So this actually is a very big feature for us. Another thing a case class has is a built-in copy method that is really helpful when we need to clone an object or change one or more fields during the cloning process. So I actually just showed this in a previous video, and I have that up here. What I did earlier in the previous video was I created this larger case class. So this one has, 3, 6, 7 different fields in it right there. And this is game state for a football application, American football application. So then I show right here, I create the first state for a game. And the way you read this is I have the ball is true. I'm on the 25-yard line right here. It's first down, 10 yards to go. The score is 0-0, and there's 3,600 seconds left in the game right there. And then what I do here, I'm mentioning the copy method over here. So what I do here is I create the second game state from the first game state. And the way I do that is I call this copy method on the first game state, and then I pass in these parameters that I want to change. So this creates the new game state S2 from the initial game state S1. And when you call copy, you pass in these parameters. So what I'm saying now is the field position changes. So it's now going to be on the 29, the down changed, the distance changed, and the time remaining changed. Nothing else changed. So I have the ball did not change, and the two scores did not change. But I want everything else to change, and this shows the way you do that with that copy method right there. And then this line right here shows that new resulting game state right there with the new values. And just to demonstrate that a little bit more, we can copy this code over here. So we will start that, copy that, and paste it here. So that's a case class for a baseball team. Has 2 constructor parameters, name, and then their last World Series win. This was very big for the Chicago Cubs back in the day. So back in 1908, the Cubs had won a World Series. The 2 parameters for name is Chicago Cubs, and the last World Series win was 1908. And then in 2016, they happened to win it again. So now we could create the new Cubs parameter for 2016. And we say, well, what I want to do is start with Cubs of 1908. And I want to copy from that. And I don't want to change the team name because the team name is the same. But what I want to do is change their last World Series win was 2016. And when I hit enter here, this is going to create our new value right here. So our new value is now Cubs 2016. And you can see it has the same name, Chicago Cubs, and then the year now is 2016 for this value here. So that's the way the copy method works. And again, the only thing you have to put in here are the values that you want to change. So if baseball team had 10 parameters inside of here, 10 constructor parameters, and I just wanted this one to change, I would still just put this one in here. It would keep the other 9 the way they are, and then it would just change this one right here. And I'll refer to this process as update as you copy. And again, this is another big functional programming feature we use, in part because everything in functional programming is immutable. And basically, you could think of this as cloning. So you're actually cloning the 1908 value to create this 2016 one, and then just making this change during that cloning or copying process. And now another thing you get here is generated equals and hashCode methods. So if I had another niece and her name is Hannah, then I can copy and put that in there. And now I can test is Hannah equal to Christina? And that will say no right there. So these generated equals and hashCode methods are really nice for equality comparisons. And again, they let us use our values as keys in sets and maps. And that's another situation where equals and hashCode methods are very important. And the last thing I mentioned was that these have two-string methods. So again, I could say Christina, and you'll see actually the two-string output there, but I could also just type that in like this, and you'll see the same result right there. So just as a personal nitpick, one thing I don't like is that we don't see Christina and niece inside of double quotes here. And both of these are strings. So in my opinion, they should both be enclosed with double quotes here, and they're not. But other than that, these two examples do show that we get a default two-string method. Whereas if I type in Al, which was that value that I created earlier, when I said val Al equals human of Alvin, like that. And now if I type Al, that's what the two-string method looks like by default. And I can also type in al.toString to demonstrate that again. So this is what you get by default with a regular class. And with a case class, you get much nicer output, which looks like that. And the next part here, I'm not going to do at the command line, so we can scoot this back over here. So what I did in the book back in the day was I showed the source code that the Scala case class generates for you. And the way you do this is you create a case class, and then you disassemble the resulting .class files with the Java P command. And what I did here, so this one is a case class named person. And just to make the difference even larger, I created these as var fields. So it's a case class with a var field there and a var field here. I compile that with Scala C, and then I disassemble that with Java P. And this creates, I should mention, this creates two class files. One is person.class, and the other one is person$.class. So I disassemble person.class with this command, and you can see that this signature goes on for many lines right here. And then I disassemble person$.class right here, and you can see many more lines right here. And so that's a lot of source code when you declare a class as a case class, and that includes getter and setter methods, and then all those other methods that I just talked about, which are copy, hashCode equals, toString, apply, and unapply, and more. There's more that I didn't mention. And now if we scroll down here, and what I did was I just created a regular Scala class. So I don't show the source code for that. But when I created the regular Scala class, I basically just took the word case off of here. So I just had this code right here for the second example. So if I scroll back to here, now this is everything that's generated for you with a plain class. So you can see that's quite a bit different. And I believe I note that here. So the case class results in 22 more methods than the regular Scala class. And as I note here, these extra methods, that should be methods instead of fields right there, but these extra methods are really nice convenience for us in object-oriented programming. But in functional programming, these features are really necessary. All of these things, especially the apply, the unapply methods, are very nice. Val fields by default is nice. Copy is huge. I should say that in Scala 3, copy is still huge. Unapply is still huge because that lets us work with match expressions. Accessors, of course, are huge. And equals and hashCode are huge because it lets us use our values in the way that I described. And now the last thing I want to mention here is I thought in the book and in this course as well, I thought a quick review of case classes is important because the next thing we're going to do is really dive into the case class copy method. And because we don't mutate objects in functional programming, we need something else to create updated instances of our objects when things change. And the way we do this in FP is with the copy method. So I just showed how that works. And in the next lessons, I'm going to show even more examples of how that works.